It's like a program that makes programs. Hi, welcome to Shitty Fun Time Extravaganza Tutorial Hour, aka Coding Adventure. On today's episode, without explaining anything on the screen, I'm going to paste in this pragma warning disable, copy some code into here, and then I'm going to run it, and you can see that we have hello world. We have a read line here with a string, and we have, a write line with a string, and we have a read line here for no reason other than to keep the window open. As you can see, if we comment this out, which is what that looks like, you can see the window just immediately closes. So let's talk more about the program. This is C#, it runs in an environment called .NET, and today I'm going to be showing you something called object-oriented programming. I don't want to explain it first because then that's going to bore you. I'm going to show you why it's fun. This is a namespace. This could be anything, literally. I'm going to, if I was a correct person, I would call this youtube.etc.tutorials.C# probably. But I'm just going to call this assy swizzle cheeks. And what the namespace does is it prevents identifiers from colliding with other identifiers in loaded libraries, so I don't have to worry about this thing being unique because it's within its own namespace. So I can pretty much just call this whatever I want. And today we're going to call it the Godiva Chocolate Tears. Alright, so let's call it the shit type, and let's take a look more at the language. Console.WriteLine writes an object or a value to the screen. You can write all kinds of objects and values. For example, numbers, integers, dates, times. Well, actually, it's one object called a date time. Or objects. If I run this, you can see that all of these things get written to the screen. They don't necessarily have to be strings in and of themselves. This object can't be represented as a string, so you see the type. Everything in .NET has a type. That is part of object-oriented programming. All of these objects have types. If I hover over them, you can see this is a system.string. This is a system.int32. There are 32 bits in this integer. This is a date time. This is just an object, which has no function because it has yet to be given a function through inheritance, which you'll learn in a second. So let's create a new type of object called, we need to be within our assy swizzle cheeks, called a cat. And there'll be a reason that I'm picking a cat, and you'll see in a second. But here's what we're going to do. We're going to simulate some cats. So cats have life, and cats are either alive or they're not, and they have an age. So these are called fields. They're basically attributes of the cat. And you can see that each of them has a type, which I've defined here. The other thing that I'm going to do is up here I'm going to create a cat. Creating a cat is called instantiating, creating an instance of. I'm going to create an instance of this class. I'm going to create an object of a type cat. So let's create a variable called C. C doesn't have an object in it yet. It's just a variable that holds an object. And in fact, you can see that there's this hovery thing here that's upset because I declared the variable and never used it. I really don't like these squigglies, so I'm going to paste in another pragma warning disable to turn that off because I'm going to declare a lot of things that are not going to be used for a few minutes. So right now, there's nothing in C. It contains a null, and if I try to write it to the screen, you'll see that I get a very, I apologize for that. You'll see that what I get is a build error. In fact, I can't even build the program because it literally knows that there's nothing in C. Now I could fake it out by specifically saying that it's null and then trying to call it. And you can see that console.WriteLine actually checks for this, and we'll just skip over it. If there's plenty of functions that will throw an exception, or an error, basically, if you pass in a null value. And also you can't really access any members of null, so like if I try to, let's just say convert it to a string before I display it to the screen, you'll see that it actually crashes the program because, as you can see here, there was a null reference. Literally, this is null, and that's the problem. So let's stop the program, and let's set it to a new cat. And let's get rid of this. And you'll see if we run the program. I guess maybe it's hung up because of that. There we go. You'll see that what we actually get is an assy swizzle cheeks.cat, which is the namespace dot the class name, and it's because there's no string representation of a cat, at least not yet. So this is what gets printed to the screen. Now let's get rid of all these other things that we don't need anymore. And let's take a look at our values here. So we have life, alive, and age. Now let's say we wanted to assign a value to one of those things. You can see that if I hit C and then dot, I don't really see any of those, and that's because they need to be public. Fields and members are basically anything that's inside of this class, anything that's part of the cat, anything that each cat will have as a member, whether it's a field or a function or a method or a property or an event. These are members, and members have access modifiers, which tell the system where this variable, this field, is accessible from. Without this public, it's only accessible privately within the cat, and the whole point of this is that you don't want to expose the insides of the cat outside the cat. In real life, when the cat, lives, it's living as a result of functions going on within the cat. There's nothing outside the cat that's acting upon it every so often to actually process its heartbeat and all of that. Obviously, there are external functions like feeding the cat, and there's, events that occur like the cat meowing, but all of the functionality of the cat is inside the cat. Just like a car, all the functionality of the car is inside the car. The engine of the car doesn't need to be publicly accessible because that is private to the car. The cat's heartbeat, while you can make signs of it accessible if you need to detect it, the heartbeat itself and its presence and the implementation of it and the thing that creates it and deletes it needs to be within the cat. So this is where we're going to create these as public so that we can access them from outside. And if you can see, we can say, okay, well, the cat's now alive. And we can run the program and we still get a cat. Let's remove the hello world at this point. And let's take a look at the cat. Now, if we go back up here and we type c dot, you can see that there's 4 functions that we never created. Equals, get hashcode, toString, and get type. And these actually are inherited from object. Every class inherits from object, and object has these 4 functions. So basically, every object in the universe has these 4 functions. Equals compares it to another object to see if it's the same object. Get hashcode creates basically a number based on the value of the object so that it can be used in like hash tables and other things. Get type returns the type of the object, in this case, cat. And toString creates a string representation of the object. Now, in this case, the toString function literally just returns the string that contains the type of the object because we haven't actually told it how a cat becomes a string. So let's go ahead and do that. And the way that we do that is we override the function that we're inheriting from the object class. And you can see that it gives us the 3 functions that we can override, and toString is one of them. And you can see that by default, Visual Studio has thrown this in here because it basically says, okay, well, return the value of the base class, the object, toString, which in this case is not what we want. That is the type, the name, the assy_swizzlecheeks.cat, and we don't want that. We want to return the cat's name. So let's return cat, but we can also say that the cat has a name, which is a string. And if the cat has a name, we want to refer to it by its name. Otherwise, we should just call it a cat. So the way that we can do this is we can say string.is null or empty, which will test to see if the name is there or not. And we can say, if it is null or empty, just return cat. Otherwise, return name. And this is basically a shortcut for an if statement. Basically, this question mark and colon sequence says, hey, test this and do this if it's true, this if it's false. And as you can see, at this point, if we run this, now we see cat. And if we set a name for the cat, like Bob Vila, you'll see that Bob Vila shows up on the screen. Now let's go one step further. Maybe sometimes we want to show some statistics about the cat. For example, its age and its amount of remaining life. So let's say that it has 6,500 life remaining, and it's, 32 old. And I'm not defining any units yet. I'm not saying these are years, but these are just arbitrary numbers. But let's say I want to return some statistics. Now, I don't always want to return statistics, so I don't want to necessarily tack them onto the end of here. But I could just define another function. For example, public function, or public string, to statistics. And then from there I can say, hey, I want to return this. Or actually, I can just say return to string. And then on the end of that, I can say, age is age. And then we'll convert that to a string because it's a number. And we'll say life. And that basically returns the name, which is coming from this function, followed by all that. And this should work. If I say c.toStatistics, you'll see that it does work. But really, this doesn't need to be a separate function because we can actually make this a function called toString as well, except we can say show statistics as a Boolean. That comes in here. And you'll notice that the error goes away, and we can have multiple toString functions as long as they differ in what parameters they take. So I can actually just say, we'll return toString, and then if show statistics is true, we'll also show the age of the and the life of the object, and if it's not, we'll just show nothing after that. And as you can see, I probably need to do that. And now if I want to say toString, this should return just cat, and if I say toString true, this should return cat with the statistics, as you can see. And that is what's called function overloading. Overloading is when we have multiple functions with the same name with different signatures. This is called a signature. Overriding is what we did here to redefine, re-implement is the correct term, the function that was already implemented by the base class, in this case object, which is implied, so we don't have to actually say that it inherits object. We can explicitly say that it inherits object because it does, but I don't know if you can tell, but it actually just grayed itself out. The color changed on it. Actually, no, that's a lie. The color changed because I chose a capital letter, which is the actual class name. The lowercase object is a keyword in C#, so that's why the color changed. But there are places here, like for example, these using statements will gray themselves out. I can't really see if you can tell the difference, but these are grayed out and this one is white. And the reason is because we are not actually using these, contrary to these statements. And this basically means is that we're using things in these namespaces so that we don't actually have to say system.string or system.console. We can just say console. I can easily just remove this using .system, and what you'll see is that if I go down here, all of my console statements start now being fucked up. But I could just say, I can just fully qualify them if I want to and just say system.console. But I don't want to do that because that's retarded, so we're just going to not do that, and we're going to put our using system back up here. I don't know anyone that doesn't use system. So there you go. Now let's simulate some cats. So the first thing I'm going to do is I'm going to get rid of this, and I'm going to replace it with a while statement. And what a while statement does is it loops this particular logic for as long as this statement is true. And in this case, I put true here, so it's going to continue to run this forever, at least for now. I'll change this later. What the fuck are you freaking out about? Why is that an issue? Unsearchable, unreachable code. Yeah, Visual Studio actually knows that this is never going to run because this loop will run forever, so it's making me aware of that fact. As a result of that, I'm actually going to add another warning disable for 1062 because it's a pain in the ass. So anyway, if I run this, right now I'm just printing the current date time to the screen, and I'm clearing it so that it refreshes in real time. As you can see, it's flickering like crazy, and the reason for that is because we're not actually waiting at all. So let's wait here for a second. And the way that we wait is we basically take the current thread and we can sleep it. So we have to go into system.threading, and we go thread.sleep, and let's put 25 milliseconds in there, and let's see if that looks any better. All right, much better. I can actually see the number now. Maybe we'll slow it down one more notch, and let's say 50. Yeah, that looks fine, at least for our purposes. So anyway, what we can do if we really want to is we can remove this from here and go up here and actually use system.threading, and now we don't need to have a ridiculously long... What is your problem? We're already using system.threading. I apologize, I'm retarded. Thread.sleep 50. That's all we needed. Now, let's move on. I'm going to define two cats, and I'm going to call them Bob and Sally. Like so. And I can sit here and I can say bob.age equals, well, honestly his age starts at 0, so I can say bob.life equals 6500. But we can do what's called an object initializer, so when we say new cat, I can say, yeah, and the age is 0, and the life is 6500, and alive is true. And same thing here. And honestly, age is going to be 0 no matter what, because it's an integer, and integer's default value is 0. But it is good practice to set it in code. Now, honestly, it's not good practice to set it in code here, because that, first of all, I put a semicolon instead of a comma. But it's not good practice to set it here, because again, this is outside the cat. This should not be anything that the outside world has to determine. Down here is where we should explicitly state that the age is going to start at 0 if no one else has set it. And what we're going to do here is we're basically going to say, okay, we're going to write Bob to the screen, and we're going to write Sally to the screen. Let's run that, and you can see that we have two cats, and we didn't name them, so let's name them Bob. Sally. And the other thing that we can do here is we can say that to string true because we want our statistics. And you can see we now have their names and their ages and their lifetimes, their lifespans, the remaining life counters. So one thing that we can now do is we can start decrementing their lifetime, which is how we will simulate their lifespan. And you can see that, very interesting. Why does this happen? Well, here's what's happening. We're creating a new Bob and Sally every time we go through this loop statement, this while statement. So what we should actually be doing is creating a single Bob and Sally up here, out of the scope of the while statements. And now, as you can see, their life ticks down in front of your eyes. Now, nothing stops it from hitting 0, or for going below 0, so it's just going to go into the negative numbers when it hits 0. So first of all, we need to make this go faster than this because we're going to want to do this multiple times. So instead of subtracting 1, which is what this operator means, it means we're decrementing the value of Sally's life, we're going to decrement it by 25, which is what this operator means. It means we're going to set it equal to its current value minus 25. It's literally the same thing as saying Sally's life is Sally's life minus 25. They both do the same thing, and you can see that they'll tick in sync with each other here. But the other thing that you'll see is that there is no bounds checking, and this will go below 0 into the negatives, and it will continue to go into the negatives all the way until it overflows outside the possible range of integer values, in which case it'll throw an exception. So the next thing that we need to do is, this is bugging me. We have a separate variable to detect or to denote whether the cat is alive or not, which is very helpful because I want to be able to do things like if cat.alive to see if it's alive. But we don't need to have a separate variable for this because this can be determined by whether this number is greater than 0 or not. So what we're actually going to do is, what some people would probably do is create a function. They would probably say, oh, okay, well, I'm going to, create a public boolean is alive, and I'm going to say, oh, okay, well, return, is life greater than 0. And that's totally acceptable, and it completely works, and you can actually go up here and say, let's add a space and say that is Bob alive. And we can convert that to a string, which we actually have to. So like that. And you can see they're both alive. And when this ticks down to 0 and goes below 0, that should change to false. As we'll see. I have to prove it out. And you can see that they're no longer alive. So what we could say here is if Bob.is alive, then subtract, and if Sally is alive, then subtract. But what's wrong with this? Why wouldn't we want to do this? Why wouldn't we just want to do that? Because this completely works. When this hits 0, they're going to go down and become not alive. Let's reduce this to 3500 for now. But as you'll see here, this completely works and does exactly what we want to do. And now they're dead, and that's the end of it, and the timer's no longer ticking. Now, the reason why this is improper is because in object-oriented programming, specifically .NET, specifically C# and VB, functions are really reserved for things that produce computational logic, things that return a different value each time, things that access the network, convert a number, things that actually do something. If we're just accessing data, then this is better suited for a property. And the way that we have a property, all that basically is that this field up here, this alive field, all we have to do is this. Boing. And now, it is computationally and dynamically bound to whatever I put in here, which is life greater than 0. So now instead of alive being just a regular variable, a field that gets set and retrieved as needed, it's actually more like a function where it's actually running this code when it needs to be retrieved. But to things outside the cat, it looks like it's just a normal field, a variable. So out here, instead of is alive, I can basically just say if bob.alive. And you'll notice that in the menu, it shows up as a property and not a purple function. I also don't need double parentheses to access it. You'll also notice that now I can't set it because it's read-only, which is correct. I shouldn't have to tell it that it's alive. I'm already setting its life. So we really don't have to worry about that. And also I had an error here, so there we go. Let's fix that. And as you can see, this should work perfectly fine, just as you would expect. Now, the next violation of object-oriented programming principles we have is that the logic for calculating the cat's life is outside the cat. So the way that this should really work is that inside the cat, we should have some reusable code, perhaps a function called live, that determines how the cat lives. And if all we're doing is decrementing the life by 25, then this is rather simple. And then all we have to do up here is say, bob.live, sally.live. And what do you know? The other thing is that while the name probably should come from outside the cat, the cats don't name themselves randomly, the lifespan of a cat really is not assigned to it by its creator, at least not in this case. So the other thing is that its life should probably be determined by the cat itself. Now, I could just come up here and say life equals, 3,500, but I actually want this to be slightly random. And in order to be slightly random, we have to actually run some code to set the lifespan. Now, should I create a function here? Because if I create a function here, that means that someone has to call it. And what if someone starts using my cat without setting the lifespan on the cat, without giving it life? Once again, that should be a thing that shouldn't have to be called externally. So what we can do is we can create what's called a constructor. And how you can create a constructor is basically just create a function with the same name as the class, and you don't have a return type. And this code will get called anytime a cat is created. And in here is where we can basically say life equals, in this case we'll say 3,000. I'll remove this from up here. And as you can see, we're not setting the life anywhere up here, but when we start the thing, it begins at 3,000. And that is because once we created the cat in this step, it jumped down and ran this code. Now we can randomize it. And the way that we randomize in C# is we create a new random object. So let's create a new random object. And the way that the random object works is it feeds you a stream of random numbers, or pseudo-random numbers, and you pull the next random number out of the slot. And you can just get the next number, which is going to give you a non-negative random integer from 0 to the highest maximum number of you can have in an integer. Or you can specify the lowest and the highest. So I want a number that's between 3,000 and 4,000 for right now. And if we run this, you'll see that we got some random number. I didn't see what it was, between 3,000 and 4,000. But you'll also notice that both Bob and Sally's lifespans are in sync. Oh, and the other thing is we have to put the check in for the negative numbers. So let's go ahead and real quick, we can just say if alive, then life goes. But you can see that the same number, I'll run it again, you can see that the same number is chosen. They're perfectly in sync. So why is this so? We created a new randomizer within each cat. This does not share the same randomizer. But actually that's the problem, is because we're creating two cats simultaneously in the same tick, at the same millisecond, what's happening is that we're creating two randomizers also at the same time, and randomizers are pseudo-random. They use the computer's clock to generate their seed number. And as a result of that, we're both calling the next available random number, which is the first available random number, on both randomizers simultaneously, which are the same number. So what we actually want to do is we don't want to have a different randomizer for every cat. We want the same randomizer. So instead of creating a randomizer in the constructor here, well, the first thing is we can move this out of the constructor up into the cat itself so that the cat has its own randomizer. But this obviously doesn't solve the problem because it's still going to create one randomizer per cat, just like it creates a different name for every cat, a different age for every cat, a different lifespan for every cat. Not that you can tell from here since they're set to the same value. So how do we create a randomizer that's the same for every cat? Well, the most obvious answer is to put it outside the cat and put it out here and pass it in and make the randomizer here. And then when you create a new cat, you have to set the randomizer. But that's a pain in the ass. And people outside the cat shouldn't have to worry about how the cat's life comes into play. So really the answer is to put it here, but to use a keyword called static. And what static does is it means that this is shared among all cats. It's not actually part of each instance of a cat. It's actually part of the class of the cat. So if we run it now, you'll see that they are not in sync. They are slightly out of sync because they had different numbers and they will both die at different times. Boom, boom. Sally died first. The other interesting thing to note is that because we're decrementing by 25, even though we stop counting down, we do wind up with a less than 0 lifespan. So what we should probably do is say, if alive, life is da 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 da, else life is 0. And that will solve the issue of that. Now let's scale this out a little bit more. Instead of just dealing with Bob and Sally, let's deal with multiple cats. So the first problem is we need to decouple this from being explicitly defined cats. And we need to create a list of cats. So in .NET, there's a bunch of things called collections, which are classes that contain other classes, containers, if you will. And one of them is a list. So let's create a list of cats. And this is what's called a generic type. It's basically a type that takes a parameter, not as the function that creates the type, but as the actual type. So we can create a list of cats, an ace of kidneys, a bag of bananas. So we can create a list of cats, and we'll call it the cats, and we'll instantiate that to a new list of cats. And now what we can do is we can, instead of having 2 cats, we can have as many as we want. But for now, let's just create the same 2. We'll create cat C equals new cat. And the only thing we have to really set now is its name, so we'll say it's Bob Vila. And we'll add it to the list of cats by using cats.add. And let's create another one. And we can reuse the same variable here because we've already added it to the list, so we can redefine the C now. And we'll call it Sally Field. Actually, no, let's call this Vanna White. And let's add that to the list. And now down here, instead of calling these explicitly, what we can do is we can create what's called a for each. And we can say, hey, for each cat, and we have to give it a variable, so we'll call it n. For each cat in cats, we want to do some operation on them. So the first thing we want to do is have them run their life span cycle. And the second thing we want to do is we want to print them out to the console. So instead of Bob, the toString, we want n, the toString. And then we can remove this. And if all goes well, we should now basically get pretty much the same thing, except now it's Bob Vila and Vanna White. Perfect. Now, the other interesting thing that we can do is now, instead of saying while true, we can say while there's more than one cat, or while there's any cat. So we can say while cats.count is greater than 0. And now, as long as we have cats in the cat collection, we'll continue to monitor them on the screen. Now, the next thing that we can do is we can have the cats drop out of the cats collection when they die. So after our live here, you'd think that we could probably just say, hey, okay, well, if not and alive, and that's the operator for not in C#, then you'd think that you could say cats.remove n, and it would remove it from the collection. And that actually does happen. When we run this, it will go through the first time, it will run n.live and decrement the counter. It will, the first time that this actually happens, the first time the cat dies, it will actually go in and it will remove it from the cats list. And it will then continue and print the thing. The problem is that when it gets up here, the cats list is going to be modified, and certain collections cannot be modified while they're being enumerated. So you'll see that when we actually run this, and what happens is that when this dies, it's a ticking time bomb. When this hits 0, it's going to throw an exception, because, as you can see, we shouldn't have modified the cats while we were looking at the cats. So it's an interesting experiment in quantum physics. If you're modifying something and observing it in the same step, I don't know. So let's stop this, and let's think of better ways that we could do this. Well, the other way that we could do this is we could say, okay, well, if the cat's not alive, let's make another list called dead cats. Let's call it dead. And here, if instead of removing the cat right away while we're inside the loop, we'll add it to this other list, which we're not enumerating. And then after we're done going through all the cats, but before we restart the loop, let's just go through all of the dead ones and remove them from the normal list. And then we'll clear the dead list so that it doesn't keep trying to remove them. And this should work beautifully. What'll happen is that when this hits 0, they'll get added to the dead list, then the dead list will be enumerated, they'll be removed from the thing, and then finally there won't be any cats, the while loop will end, and then we hit the end of the program, and now we're at the console.read line, and that's the end of it. So that's awesome. Now, the problem is we want to keep the simulation going, so we need to spawn more cats. So how do we go ahead and do that? Well, we want cats to basically have their own lifespan. We want them to, at some point in their life, spawn some offspring. So let's take a look at our live function. Let's start breaking this out into bigger blocks here. So let's do this, and let's do this. And let's make some comments in here. So at this point, the cat is alive. At this point, the cat is dead. Now, if the cat's alive, one thing that we should be able to do is check to see if it's time to spawn some offspring. So I'm going to create an if statement in here, and I'm going to put some logic in here. And basically what I'm going to do is I'm going to say, if life modulo 3000 is less than 10. Now, I'll explain this in a second. And the other thing I'm going to do is I'm going to increase the default lifespan from 5,000, actually probably from 6,000 to 6,700. And then what we're going to do in here is, this is basically how often we're going to spawn children. What this means is that modulo is the remainder of division. So if the lifespan divided by 3,000, if the remainder of that is less than 10. So basically what I'm asking is, if we're within 10 of 3,000, then we hit it. Now, the interesting thing to note here is that we're subtracting by 25, and we're starting with a random number. So we may not hit this, when we pass 6,000. We may only hit it when we pass around 3,000. We may hit this multiple times when we pass 6,000 and 3,000. We may wind up with some twins or triplets. So this will be an interesting logic, a very interesting logic. So now the next problem is let's create a function to spawn some offspring. So we'll call, spawn at this point. And we'll go ahead and define a spawn, a public void spawn. And in here we need to create a child cat. So let's say create cat child equals new cat. But the problem is that we don't have any way to add it to the cats list up here. So there's a number of ways that this could be accomplished. The most obvious way is to pass in the list of cats when we call the live function. And then in the live function, say we take a list of cats, and then we then pass that in the spawn function. The spawn function then has to take a list of cats. And then finally we can say cats.add child. I'm sorry, I meant cat. And if we run this, this will actually work, or it should. Oh, that's an issue. As you can see, we've modified cats again while we're running it, so now we have no choice. We can't remove it from inside the spawn because the spawn is always going to run from inside the live is going to always run from in here. So how do we do this? This is very, very bizarre. Well, there's a number of ways that we can do this. The first thing is let's go ahead and revert all those changes. We don't need to pass the cats collection into here because, first of all, what if there is no cats collection? What if we're making cats naturally without there being a list of them that we're enumerating, like we were with just straight Bob and Sally? So what we're going to do here is let's undo all this, and we don't need to take any of that in. What we're going to do instead of passing cats in here, and let me stop the program, is what if we say that the cat object itself has a variable called offspring, which is of type cat. And what if we say, okay, well, when we create the child, we just set the offspring to that. And then we can just check it up here. After we live, we can say, if n.offspring is not null, which is what it would be if we didn't set anything on it, then let's go ahead and add that. So now that we have our dead cats, we have to have another list here called new cats, or born cats. We can't use the word new, obviously. And then from here we could say born.add n.offspring. And the next thing we want to do is we want to set that back to null so that we don't accidentally keep adding it over and over again. And then, obviously, then down here, we now have to go through cat b and born, cats.add b, and then we have to clear the born so that doesn't get cycled over multiple times, and now it should work fine. So you can see we spawned a child at the 6,000 mark, and you can see that we're spawning new children, and as those children spawn children, they're spawning children, and all that good stuff is occurring. And Vanna White and Bob Vila, they died. But, we're spawning children, and it's growing exponentially, which is exactly what you'd expect. So, let's take a look at our program now at this point. The first thing that we need to start doing is keeping track of the age of the cat, because that's been 0. So in our live function, we can just say age plus equals 1, or age plus plus, and that'll start counting that up. So now you can see that our age has, what the hell, why is that just stuck on 1? Why is that just, oh, because I put that in the, I'm sorry, I put that in the constructor instead of the live event. Or function. So you can see the age goes up, the life goes down. The age goes up a lot slower than the life goes down. And the cat starts spawning new children. So the other thing that we can do is we can say, okay, well, and to make this less out of control, we can say, okay, well, if you're going to spawn children, the age has got to be at least 30. Or maybe we'll just say 18. If the age is less than 18, then don't spawn any children. So basically, that'll keep cats from immediately spawning new children. Actually, maybe that should be 30. Probably 30 or 50, honestly. So these wouldn't be eligible to spawn children until now. So they'll start spawning children at the 3,000 mark. Perhaps there was one, and they're both going to die without any offspring. Well, the one made one, and okay, and there we go. And then that cat created some, and then this is a little bit more controlled. This looks a lot more realistic. So we're going to let that go ahead for a little bit. All right. So now the only issue that we now have is that up here you can see that the managing of the offspring is logic that's outside the cat. The fact that we're detecting whether offspring were created or not, that's fine. That's something external to the cat. But the fact that we're actually going in and setting that variable back to null means that this is not good coding practice, because this can create a race condition. What if there were two loops going side by side that were checking this cat for offspring? One of them would find the offspring and set it to null, and the other one would just see null. Or, even worse, one of them, or both of them, would actually detect the offspring at the same time, cache the offspring, and then one of them would set null, the other one would set null. Maybe one sets null while they're retrieving the offspring. It's not a good scalable solution, because multiple things could be accessing this cat other than just this one location. And the whole point of object-oriented programming is to make code that is reusable, to make a cat that could be used anywhere, not just for this particular function that loops through a list of cats and checks for offspring and sets them to null. We want the cat to work whether or not there's something out there checking it, setting it to null. The cat needs to manage itself. So what we're going to do here is, instead of this offspring jazz, we're going to create events. And events are used where you have an object and it needs to inform the outside world that something has happened or give it something. And we're going to create a born event and a dead event so that the loop that we have, our program can just subscribe to these events and respond to them without having to do gymnastics with all of this other stuff. So the first thing that we're going to do is I'm going to get rid of all of this loop nonsense, because there are much easier ways to solve this problem other than having a list of ones that we're adding, ones that we're removing. That's all nuts. Now, with that said, before we do that, actually, I'm going to leave that in place for a second, because that'll actually make the next step easier when we go to events. So let's just go to events here. Let's get rid of this offspring shit. And we're going to create two events. And in order to create two events, we first need to create what's called a delegate. And a delegate is basically a prototype of a function. It's just like a cookie cutter. It says, this is a slot that holds a pointer to a function that behaves like this. So we're going to create a delegate called birth, and it's going to be, it's not going to return a value, and it's going to produce an offspring, which is a cat. And now that we've created this delegate, which is basically a type of function that doesn't return a value and produces a cat as an offspring, we can use that as an event, and we can say birth, born. And basically there's an event called born that produces a birth, which is an offspring returning nothing. This is basically what our program will define. It will define a function that receives the offspring and doesn't give us anything back, and that's what we're going to invoke. And while we're here, we're going to also create a delegate called death, and we actually don't have to care about anything there, so we're going to say public event death died. And now, instead of doing this, we're just going to say born child, born child. The only caveat is that if we do this, we may actually wind up in a situation where no one is actually listening for this, so we should just say if born does not equal null, then born the child. I birthed myself. Likewise, when the cat has died, we should also say, we should also say, now we don't want to put it here, because here it's going to run every time the cat's dead. We really want to put it when the cat has been detected as dead. So if not alive here means that this is when it first transitions to the death state. And also, we only need to check for spawning of children if we're still alive, not if we've died. So the cat was alive, the cat is now dead. The cat has more life to live, basically. And if the cat's now dead, now we can raise the died event. So if died is not null, then we can died. Booyah. And now up here, all we have to do is, instead of all this shit, all we have to do is up here we can say that when we create these cats, we basically just say c.born plus equals, and that we can actually create a function called c.born, and c.died we can create it. We can just hit tab, and Visual Studio creates the function for us, and the function lives here. And all we have to do is say, okay, well, and we can add the offspring to the born list, and here we can add the offspring, or here we can, let's get to the died in a second. So the first problem is that the born is outside the scope, because the born list is out here. So the first thing we're going to do is we're going to hoist all of these cat lists up into the ship type class outside of the main function, so that they're accessible by other functions beyond this. Now the problem is that this is a static method, so we have to make these static, because there's only one shit type. There will not be multiple shit types, so we need to make sure all these are static. There's only one of these lists. There's one cat list, one dead list, one born list, and one main function that's controlling them all. So now that that's been done, this should work for our maybe this should not work. What is the problem? That's because that's not a capital A. So now, as you can see, give it some time, and when we hit around the 3,000 mark, we should spawn some children. Or not. Let's try that again. It's very possible that we coincidentally skipped over the number. It's also coincidental that we're not actually listening for the event handler. So actually the problem is we did add them for this cat, but we did not add them for this cat. So let's add it again. Maybe we'll get a better luck. Or not. Alright, one more time. There we go. And as you can see, the born handler ran, and it added our thing to the born list. Now the only problem here, as you'll see, is that the children cats, we don't get to add the handler. We've subscribed to the birth and the death of our initial cats, but we have not subscribed to the birth and the death of our subsequent cats. So we can easily do that in our born handler. We can basically just say the offspring.born and the offspring.died, so that when the cat is born, we now subscribe to the new events. And now, any offspring that we have should be able to create further offspring. Well, they have been creating further offspring, if they just haven't been tracked by us. And it seems that we need to try this again. I should probably create a larger variance on the birth rate here. So let's say that this is now 15, which has a much higher chance of spawning more offspring right around now. The funk soul brother right about now. And hopefully right about now we create more children. Yep, so there you go. So now we have events and we're not having to monitor a field on the actual cat. Let's fix up some other things that are not object-oriented proper. OOP proper. So the next interesting thing is that the lifespan of the cat should not be able to be set from outside the cat. We're setting it inside the cat. The lifespan should never really change other than the constant, declination of it from within the cat or other events where it goes down. But we shouldn't be able to set it outside the cat. It should not be public. So we can actually make this private. We could have just removed the word public, or we could just make it private. And actually we have 0 errors because we're not really referring to the life outside of the cat, which is really nice. The only place that we're printing it is here. Now we may want to refer to the life outside the cat, so we probably should create a public variable, or public property rather, because we don't want them to set it. So we can create one. Let's create it with a capital L, and that's often a common naming convention is in C#. You use a private variable with a lowercase name, and then you use a public property with a capital name, and you just return it. And now we have a way of accessing the lifespan without anyone outside of our class being able to set it and muck with the interworkings of our class. Because that is why object-oriented programming is reusable and very helpful, very rapid application development, is because you don't have to know about the inner workings of the objects you're using. They're just black boxes. So we have our property for lifespan, we have our property for alive. We should really have the same thing for age. So let's go ahead and privatize this and create a public int age and return the age, the internal age, just like so. And again, that wasn't being accessed internally. And the name here, the name is public, and the name probably should be able to be changed from outside because this is a cat, so, the owner should be able to rename the cat. And we have our randomizer here. The randomizer can probably be private. And we have our events, and those obviously need to be public. So this obviously is relatively straightforward, and the spawn event should probably be private because we don't want people from outside the cat calling the .spawn event needlessly, because I'm not aware of any way where you can, do something and the cat immediately spawns a child without, any natural process occurring. So at this point, I think we're pretty much set. I think our cat looks relatively good. The problem that we have with our dyed handler is that these event handlers are not typical. The typical event handler does send additional data that's necessary, like this offspring, but usually sends something called the sender, and the sender is the actual cat that's causing the event. So let's go ahead and send the sender in these cases, in addition to the event arguments. And what this is going to do is it means that when we send dyed, we want to send this. We want to send me, my current cat, the cat that we are inside of right now. And likewise, here in our born statement where we're raising the born event. And now outside here, the only thing that we need to do is we need to modify our signatures of our event handlers. And what this now allows us to do is in our dyed event, now that we know that we're receiving the dyed event, we can actually add the dead cat to the dead list here, and now we don't have to check for it here. So you can see this is turning into really nice code on the customer side, on the user side, the consumer of the cat. You can see all I'm doing is creating a cat, setting some event handlers, and then calling the live function. And you can see here that everything operates as usual, and hopefully when the cats die, they disappear from the list because they are now being tracked in the event handler, not checked every tick for their living status. Because that they are already being invoked every tick to live, that function can easily dispatch the death. So let's clean up some more code here. We don't have to do these list gymnastics if we actually, let's get rid of the dead and the born list, because that's a piece of shit. And one tactic that we can do, because we have a relatively small list here, is when we enumerate our list, all we really have to do is say, let's get rid of all of this shit. Yeah, we don't care about any of that. All we have to do here is say, for each n in new list of cats. And what this actually does is create a copy of the list, and it enumerates that. And we can actually go one step further, and we can say, using copy list cat, actually copy as copy, oh my god, okay, hold on. List cat copy equals new list cat of cats. What this actually does is this goes one step further, and it declares this copied list in a scope within which, tell me this is, it's fucking not disposable. Okay, so that's fine. That means that we actually don't have to dispose of it, and this is perfectly fine. Some types of objects, you actually, they have an overhead. They take up space. They have resources that need to be disposed of properly, etc. And in those cases, the using statement allows you to create a smaller scope. Normally, when you declare variables here, or instances of objects rather, they're valid either until, the end of the current method, which is if they live on the stack, They live on the stack. Or if you start creating references to them, then they become allocated on the heap, and then they actually have to be tracked. So we don't want to create a whole bunch of list of cats if they're not going to be cleaned up properly. But in this case, they're not disposable, so we don't really have to worry about calling the dispose function on them. There's going to be some overhead here, but it's a hell of a lot better than creating 3 different lists and having to have all these for each loops in every tick of the cycle. So instead of just saying dead.add, all we have to do is say cats.remove. The other thing that we can do, I'm sorry, in this case, cats.add, and this should work flawlessly. There is some work that we would have to add if we had multi-threading. We would want to lock, in this case, we would want to do this. These operations. Like so. Along with this loop here, or actually this function. What I would do, what I would specifically do, because we can't use it using, is I would say in copy, then I would say lock cats, and then while we have the cats locked, that's where I would create the copy. I'd say list of cats copy. So it's a new list of cat. I'm sorry, I said cats. So I would do that, and then honestly, the next problem is that this needs to be declared up here because it's inside the lock, and the lock is its own scope, and that's not the way it works. But that should work. And what this actually does is this creates a synchronization lock. So when the program hits this lock, it actually creates a mutex, and it says, hey, are there any other threads locked on cats? And if there are, I have to sit here and wait for them to be free. So in other words, I'm not going to go and create the copy of the list of cats while someone is in the middle of modifying it. Now, in this case, it honestly doesn't matter, because the only thing that we can't do while we modify the list is enumerate it. And we're not enumerating anymore, we're just copying it. But it's very possible that the copy method, the instantiation here that creates the copy, in and of itself has to enumerate it. So it's still a good idea not to be changing the cats while you're using it. And even though we're only using one thread, so only one thing is happening at a time here, it's very possible that your user, or a user that's using your cats, in this case, are often multiple threads, and they're writing to and reading from your object at the same time on multiple different processors or multiple different cores. So it's very important to keep that in mind. A lot of people don't think about race conditions like that. Why did these all die? Is that typical? Are these results typical? I don't know what happened. That should not have happened. There we go. Okay, it was just a coincidence. So yeah, so that's that. Now we're going to get into real fucking shit. Now here's the shit that I really wanted to get into from the beginning of this. Is, let's say we don't want to deal with just cats. Let's say we want to deal with multiple types of animals. This is where this becomes amazing. So the first thing that we can do is let's rename our cat to animal. So I'm going to hit F2 here. And actually I'm going to, And I'm going to say animal. And I'm actually going to rename everything. And literally everything, every reference to cat, whether it's in comments, whether it's in strings, has been replaced. Everything is an animal now. And everything still works the same way it was. But we're going to do something a little bit different here. I'm going to now create a cat that inherits the animal. And I'm going to go back up here, and I'm going to say, these are still cats. This is a list of animals. And it's called cats. Actually, let's rename this to animals. Oops. To animals. And everything here is referring to animal, other than I just created 2 cats directly instead of creating 2 animals. And you'll notice that this continues to work. Now, one thing I'm going to do is I'm going to stop this, and I'm actually going to put in our statistics statement down here, I'm actually going to put in the type that we are. So I'm going to say type, and I'm going to add in getType.name. And what that's going to do is that's going to add the name of the type of the object that the animal is running. And what you can do is you can see that the first 2 that I created are cats, and then we spawn some animals. And the reason for that, obviously, is because when we spawn a new animal instead of a new cat. But the thing to note here is that our cat is a class that's inherited from animal, so it can be used interchangeably with animal. Any place that accepts an animal, I can put a cat. I put it in the list of animals. I pass it through the event handlers. We call live on it. We do everything with the cat that we can do with an animal. I didn't have to rewrite any of the code. All I had to do was just create the class and change those 2 to cat. And you can clearly see here that by this point we're all animals. So let's change the logic a little bit, because when we spawn an animal, really the animal should be the same type as the parent child. So we can actually change this a little bit, because instead of creating a new animal, we could actually create a new whatever we are. And the easiest way to do that is to say activator.createInstance, and then this.getType should work. Hopefully. I provided a type. I provided.type cannot convert object to animal. Oh, okay, yeah, that's probably correct. We have to convert it like that. We have to cast it. What is the issue here? Cannot convert type to oh shit. I'm sorry. What the hell are you talking about? Create instance. No, this is right. This is what's wrong. This needs to be cast here. Sorry. A little out of it. So what we're actually doing is the activator is the object in .NET that actually creates or can create objects, instances of objects. So we're actually taking the type of the current animal. Even though we know it's an animal, it could be something more specific. It could be a cat. So we're taking that type, whether it's animal or cat or whatever it may be, because other things at this point could inherit animal. And we're saying create an instance of that and cast it to animal. And the reason we have to do this is because activator.createInstance returns object, because it doesn't really know what type of object it's going to create. So as a result of that, we have to take that object and cast it back into an animal. And we don't really have to do any extra checking here because we know that whatever type we are is an animal because we're in the class animal. If this was not something that we could guarantee to be an animal, we would have to actually check to make sure that this produced something that could be cast into an animal first. And there's a number of ways that we can do that, try cast. But in this case, we know it's an animal. It's some type of animal. We just don't know what type, but it's an animal, so we can do that. And now that we run this, you'll now see that the cats should produce cats, ideally. And of course, they didn't produce shit, so let's restart the program. And we'll probably create a better chance of spawning life. But you can see that now we created cat. Now notice that the string that we return when we don't have a name is still quote-unquote animal, and we can fix that really easily. Let's pause this, actually. And that's actually just down here. That's hard-coded to be animal. So let's just replace that with getType.name. And now it's actually going to return the name in the future. See? Alright, sorry, someone called. So yeah, as you can see here, now we have a whole world of cats going on. So let's create another type of animal here called dog. And we don't even have to do any logic. And let's just say that instead of let's add a dog. So actually, one thing that we can do here is let's refactor this a little bit. Let's create a function here for new animal, and we'll take in an animal because we don't know what type of animal it will be. And here's where we'll say animals.add c. Actually, here to take this and put it here and make that C, except now rename it to A because now we're dealing with animals. And also here we should probably rename this to A, just to be clear. And instead of here we can say add animal, where the hell is it? New animal, A. And actually we can be even more compact and just create a couple new animals here. And we'll create Bob Vila, create Vanna White, and we'll create some dogs now. We don't need these event handlers. We will create asshole. No, we won't create asshole. We'll create wizard. And we will create bacon. And then from here, let's run this. And you can see we have 2 cats and 2 dogs. And when they start spawning children at different rates, hopefully, we get some dogs and cats. All kinds of mixes of interesting stuff going on here. Now, the interesting thing is that the name doesn't carry over. We don't, these aren't unnamed, obviously. So let's create a naming mechanism so that these can be named by default to, match their relatives or whatever the hell. So let's shorten these a little bit. Let's say Bob, Vanna, Wizard, Bacon. And the other thing that we can do is let's create a couple more. Let's just create another cat called Hex. And we'll create a dog here. Another dog called Kira. And let's say that now, in order for... good, perfect. Now when we create the child in our spawn event, we will say child.name equals... We're going to do a couple things, actually. I want to say that, first of all, we have a reference, private animal parent, and we also have private int generation. And when we spawn a new child, what we want to do is we want to say child.parent equals this, child.generation equals generation plus 1. In other words, we want to set the child's generation to our generation plus 1, and it obviously will begin on 0. And in fact, let's make that explicit. I'm sorry, let's start assigning that's the right thing. And then we will say child.name equals child equals my name plus generation number. Except now we need a base name because the name is going to contain, let's just say, public string, private string, base name, because otherwise this will just keep adding numbers onto the end. So what we want here is instead of, so we want child.basename equals my base name, and then their name is base name and then the generation number Awesome. Let's see what this looks like. So we have all of our animals. Now we should start spawning new ones. Right about now. Oh, and we fucked up. We fucked up. How did we fuck up? Let's take a look at how we fucked up. Parent is this. Base name is base. Oh, because we never set the base name. So here's another great opportunity to use a variable, a property. This should be private. The name should be public. And what we're going to do here is we're going to do a get, which is going to return, obviously the name. And we're going to do a set, which is going to set the actual value. So we're going to take a string, and we're going to say, oh, I'm sorry, I forgot. I guess you don't fucking value. Is that how that works? Yeah, apparently that's how that works. But what I want to do is I want to say base name equals value as well. And so now, what is the problem? Animal.name is inaccessible. Okay, so now, capital name, please. Thank you. Alright. Sorry about that. So now that when we set the name, we're also setting the base name as well, which is an internal implementation detail. And now you can see that we start getting the generation number, except this is the wrong generation number, because we want the generation number of the child. I'm sorry. And now, we should be good. We could also start on generation 1, set these become 2, but either way, it's not really a big deal. As these progress, they should go into the 2s, 3s, whatever. And they should be very interesting to watch as time goes on. There's a Vanna 3, and so on and so forth, and Scooby-Dooby-Dooby. Alright, so what I've done here is I've created a queue of messages, and I'm going to create a function here that's going to show the messages to the screen. And I'll go into what this does in a second, but right here I'm just going to call show messages. And the other thing that I've done off screen is that I've actually added messages here when, in our die event, basically we just add a string to that list of strings and say, hey, this animal died, this animal was born. And now if we run it, what you'll actually see is that as animals die and spawn, we'll get messages that kind of queue down here. And it actually shows the last 10 messages and starts scrolling them. So as these start occurring, what you'll notice is that these start scrolling through. So we can keep an infinite stream of messages on here in our console down here. So now what we're going to do is, oh wow, we wound up in our last bacon one dog died. Gee golly gosh. So anyway, now that we have messages, let's create an opportunity for our animals to send us a message. So let's create a delegate for that. Public delegate void message with a string of a message. And we probably should have the animal as a sender. And we will create an event called animal message. Or let's just say new message is probably a much better event name. And what we'll do is up here we'll handle it. Up in our handlers, we'll say a.newMessage, and we'll let it tab that out into a new function. And here we'll basically just say messages.add message. And actually let's use sender.toString for the name, and then message. And now if we create messages from inside the animal, let's do that here. Let's say where we create our instance, let's just raise a message here. So say if new message is not null, new message spawning a new get type name. And even though we already have a new message, I'm sorry, this, we have a message that the child makes, this will be a message that the parent makes upon spawning, and this message actually comes through the new message. So you can actually see here that we're getting the new messages there. Now, the next thing I'm going to do is I'm actually going to let's go into our message program, our message function. And basically what this does is it moves the cursor position to a point, which I'm actually going to move down a little bit. It actually makes a copy of the messages, because as we established, we can't enumerate the messages while they're changing. So we make a copy of the messages, and that also gives us the opportunity to then reverse the messages, take the top 10, and then reverse it again. So it basically takes the last 10 messages and then prints them to the screen. But the other thing I'm going to do here is I'm going to actually set the foreground color to console color.cyan, and then down here, I will change it back. Now the best way to do this is to actually just store it, previous color. And what this var keyword does is it basically creates a variable with a type that is inferred. Now, this is not the same thing as JavaScript, where it creates a variable of just any type, and it can be anything. I can't change this once I define it as a console color. So you can see if I hover over this, it knows it's a console color. All it's doing is saying, hey, whatever I'm setting this equal to, that's the type that I want. I'm not going to sit here and type console color in here. But yeah, so I am going to say console.foreground color equals the previous color. I can't go down and now set, previous color to be equal to like 5 or something. It won't take that because that's not a console color. So it's not like JavaScript where var means that I'm just making a variable without a type. So now this should actually look a little bit better when we start spawning shit and we get a million messages and they start running into each other. So awesome. So now the next thing that I'm going to do is I want to actually have these animals make some noise. So let's turn off this message that we made in here that doesn't need to be here. And we will actually move it over to a different thing. So what I'm going to do is up in my cat, I'm going to say, well, cats need to meow. So, well, actually, you know, let's do it down here. So what I'm actually going to do is I'm going to create a private integer called noise time, and let's set it to 3000. Sure. And what we can do is we can say, actually, let's set it to different. Let's set it to 2800. And what we can do is in our life cycle, we can say, hey, you know, here's where we're checking for the spawning. Let's say if life noise time is less than, you know, 20, then we'll make some noise. And we'll have a function for noise. Public void noise. But what noise does an animal make? Well, we don't know because we don't know what type of animal it is. So, interesting. So here's what we can do. Let's leave this noise function empty, but let's call it virtual. And what that allows us to do is now we can override it. So just like we overrode the toString when we first created the cat object way back when, we can now say override, noise. And here we can just say, well, base.noise doesn't actually do anything. We can say, hey, meow. And likewise here, we can say, woof. Now the big problem is that these don't seem to have access to the new message event. And the reason for that is that because they're not part of the class. So what we actually have to do is we actually have to find a different way of calling this. So what we're actually going to do is we're going to create a private, or rather a protected function called makeNoise. And that's going to be on the animal. And down here we can say, because here's the deal. If I say private function, if I say private void makeNoise, string noise, and here I say new message noise. Actually, I should check that if new message does not equal null noise. The problem here is that this is not accessible. This is not accessible because it's private. And I can't make this public, because if I make this public, then things outside of the animals can call it. So what I actually have to do is I have to make this protected. And that allows me to call it from inside of the cat and the dog, as you can see. But from up here, if I were to say animal dot, I don't have make noise. That's not an option. And now if we go ahead and run this, we should see that periodically we have animals making noise of their various types. And the beauty of this is that all of the functionality that's common to the animals is in the animal class, and the only thing that's specific to each of the cats and dogs is what's specific to them. And we can actually go further with that. Let's say we have a sorry, my headset died. Let's say we have an annoying dog. Well, we can further override noise, and here, yip, you know? And the other thing is that we could, if we really wanted to, override the spawn. Well, we have to make it virtual down here, so let's find our spawn event and make it virtual. And we could, well, then it wouldn't be private, it would have to be protected. But what we could do is we could override the spawn event so that every so often a dog produced an annoying dog. But what I'm actually going to do here is create a virtual function that returns a type. And I'm going to say determine spawn type. And what I'm going to do is instead of creating a child of this type, we're going to create a child of determine spawn type. And then down here, we're going to say, we're going to return this type. And by return, I mean return. I am Brian. So now what's going to happen here is nothing will be different, except that if I really want to, up here, I can now override that a dog, while a cat will continue to inherit that function and will continue to make more cats, I can override determine spawn type. And I could say, okay, well, you know, actually, let's make this randomizer that's now private protected, so that our inheritance can use it. And then I can say, let's get me a number from our randomizer between 1 and, I don't know, 3. And if n is 1, then we're going to do something different besides returning what we would normally return. We're going to return type of annoying dog. And the type of operator basically takes the name of a type and turns it into an object type, a type object representing that type. This is a key word in C# that's referring to this class, but this actually turns it into an object of type system.type that points at annoying dog. So I can actually use it as an object within the code. So I'm actually telling it to dynamically change the type of what's created. So now let's take a look at the code. And what you can see is as dogs spawn, you can see that periodically we have annoying dogs that spawn. And then when they make noise, they should yip. Now we may have to debug this because I don't see any of the new children making noise. So let's take a look. How I'm going to troubleshoot this is I'm actually going to go to the yip yip statement and see if this function is ever being called. And we don't have any annoying dogs yet. Here's an annoying dog. And it is being called, so we are adding the message for yip yip. It is coming here. And unfortunately, it does not appear to be being handled. So what that tells me is that we are not subscribing to the event. So let's take a look at where we're subscribing to the event, which is right. Oh, we're not subscribing to the event. As you can see, we subscribed to the event in the original message, but we did not add to it here. So actually what we should be doing is instead of subscribing to this here and doing this here, we should actually just do new animal offspring. And frankly, the lock on the animals should be taking place in the new animal definition, which is here. So that should have fixed everything for us. Now let's go ahead and continue running it. And this one won't bark because we already killed it off, but now the new ones should yip yip from here on out. That gets spawned, assuming. Yep, there's Bacon 2. Bacon 2 is an annoying dog, and it's yip yipping. So you can see these are now making noise further on. And now you can see the power of object-oriented programming and inheritance. On the next episode, we're going to get into some other interesting things like enums, interfaces, and all kinds of wonderful stuff like attributes and pluggability, and yeah, so I want to see if this dies out in a second, or if it keeps going. It seems to be self-sustained until it's going to create. No, it didn't create them. It's going to die. It's going to die. It's going to die out. And the program will end, and so will the episode. Have a great day.